Hello students, let me introduce myself. I am Preeti Kapoor. I did my graduation in mathematics from St. Stephen's College, Delhi University and post-graduation in mathematics from IIT Delhi. I have a teaching experience of around 13 years. Now in this session, we will learn about triangles, various types of triangles, their properties and questions based on them. Now coming to the definition of a triangle, it's a polygon having three sides. So here as you can see in the figure that ABC is a triangle. Therefore, the sides here are AB, BC and CE. The points of intersection of these sides are called the vertices. So the points A, B and C are the vertices here. The angles enclosed by these intersecting sides are called the interior angles. So the interior angles here are angle X, angle Y and angle Z. Let's take up some properties of triangles now. Sum of all the interior angles of a triangle is always equal to 180 degrees. That is, if we refer to this figure, the interior angles here are angle X, Y and Z and they will add up to 180 degrees. Another property says that sum of an interior angle and the adjacent exterior angle is equal to 180 degrees. That is, here X is an interior angle and its corresponding exterior angle is P. Therefore, X and P will add up to 180 degrees. Similarly, Y and Q will also add up to 180 degrees and similarly Z and R also add up to 180 degrees. The measure of an exterior angle is always equal to the sum of the measures of two interior angles of the triangle not adjacent to it. That is, if we look at this exterior angle P, the interior angles which are not adjacent to it, or we can say the interior angles which are opposite to it, are angles Y and Z. Therefore, P will always be equal to Y plus Z. Similarly, R is an exterior angle and the interior angles which are not adjacent to it are X and Y. So X plus Y is equal to R. Similarly, Q is an exterior angle and the interior angles not adjacent to it are X and Z. So X plus Z will be equal to Q here. Now this property says that the angles opposite to equal sides of a triangle are also equal and vice versa. That is, if two sides are equal, then the interior angles opposite to them are also equal. Also, if the two interior angles are equal, then the sides opposite to these angles are equal in length. Now the next property says that the sum of the lengths of any two of its sides is greater than the length of the third side. So in this triangle, if we take the lengths of the three sides as A, B, C, then A plus B is greater than C, B plus C is greater than A, and A plus C is greater than B. Please remember these inequalities are strict inequalities. This property talks about perimeter of a triangle, which is the sum of the lengths of the three sides of the triangle. So if we take the triangle QRS here and take the lengths of its three sides as ABC, then the perimeter, if I represent by the symbol P, is equal to A plus B plus C. This property says that the sum of the lengths of any two of its sides is greater than half of its perimeter and each side is less than half of the perimeter. That is, A plus B is strictly greater than half of P, B plus C is strictly greater than half of P, and A plus C is also strictly greater than half of P. Also, A is less than P by 2, B is less than P by 2 and C is less than P by 2. The area of a triangle is given by half base into height. So in this triangle PQR, you can see that the base is QR, which is taken as B here, and the height of the triangle is PS, which is taken as H here. So the area of this triangle will be half into B into H. This is another formula for the area of a triangle, which is called as the hero's formula. In this formula, S is the semi-perimeter, that is half of the perimeter of the triangle, and ABC are the lengths of its three sides. Now the next property says that if we are given two sides of a triangle, then its maximum possible area is when we take these two sides at 90 degrees. That is, if the two given sides are of the lengths A and B, and we take the angle between them as 90 degrees, then we get the maximum possible area, and this maximum possible area will be half base into height, which is half into B into A, that is half product of the two given sides. So in short, we can say that if we are given two sides, then the maximum possible area that we can have is half into product of these two sides. Now coming to the types of triangles, with regard to their sides, triangles are of three types: scalene triangle, isosceles triangle, and equilateral triangle. A scalene triangle has none of its sides equal. Isosceles has two sides equal, and therefore the two interior angles opposite to these equal sides also equal. An equilateral triangle has all the three sides equal, and hence all the interior angles are also equal. The area of an isosceles triangle is given by this formula, where C is the measure of the unequal side and A is the measure of one of the equal sides. Area of an equilateral triangle is √3/4 side square. With regard to their angles, triangles are of five types. The first one is acute triangle. If all the three angles are acute, that is less than 90 degrees, then such a triangle is called an acute triangle. A triangle is called obtuse if one of its angles is greater than 90 degrees. A triangle is called a right angled triangle if one of its angles is 90 degrees. Now a very important property related to right angled triangles is the Pythagoras theorem, which says that hypotenuse square is equal to perpendicular square plus base square. Now hypotenuse is this slant line ln, which we have represented as h here. Perpendicular and base are these two sides of the triangle that enclose the 90 degree angle. Therefore, this vertical line is the perpendicular, which we have represented as P here, and this horizontal side MN is the base, which we have represented as B here. So, the theorem says that h square is equal to P square plus B square. These are some famous Pythagorean triplets. Pythagorean triplets basically means that the possible lengths of the perpendicular, base and hypotenuse respectively of a right angled triangle. Please remember that any multiple of these triplets will also be a Pythagorean triplet. Now in a triangle in which the interior angles are 45, 45 and 90, the ratio of the lengths of its sides AB, BC and AC are 1:1:√2. In a triangle which has 30 degree, 60 degree and 90 degree as its interior angles, the ratio of the sides AB is to BC is to AC is equal to √3:1:2. Now let's take up some questions. In this question, we are given two sides of a triangle as 5 centimeters and 12 centimeters. We have to find out of these four options which is the possible area of this triangle. Now in the previous slides we had discussed that if two sides are given, then the maximum possible area that the triangle can have is half into product of these two sides. That comes out to be 30 centimeters square. Now any option which is more than 30 is not a possible area. Therefore, option number 2, 3 and 4 are ruled out and we are left out with only one option, that is the first option is the answer. In this question we are given that the sides AD and CD are equal. Therefore, the angles opposite to these two sides have to be equal. So let's call them as angle X and angle X. We are also given that the sides BC and CD are equal. Therefore, the angles opposite to these two sides will also be equal. So let's call them angle Y. Now BCE angle is given to be 96 degrees. If we consider the triangle ABC, then 96 degrees is the exterior angle and its two interior opposite angles are angle X and angle Y. Therefore, 96 degrees will be equal to x plus y. If we consider the triangle ADC, then this angle y is the exterior angle and its two interior opposite angles are angle x and angle x. Therefore, y is equal to x plus x, that is 2x. So if we substitute this value of y here, we get 96 is equal to x plus 2x, that is 3x is 96 degrees. Hence, x comes out to be 32 degrees. Now, we were asked to find out the angle DBC, which is the angle y here. So, y is twice of x, that is 64 degrees. Now, in this question, we are given that this angle is 90 degrees. This angle is given to be 60 degrees. And if I call this angle as x, and we know that sum of the interior angles of a triangle is always 180 degrees. Therefore, the angle x comes out to be 30 degrees. Now, it's a 30, 60, 90 degree triangle, and we had discussed in one of the previous slides that in such a triangle, the ratio of the lengths of the sides AB, BC and CA is given by 1 is to root 3 is to 2. Now we are given that the side AC is equal to 10, which is 5 times of its ratio. So the other two sides will also get multiplied by 5, giving the measure of AB as 5 and the measure of BC as 5 root 3. So the length of BC is 5 root 3. Now in this question we are given that this angle is 90 degree. This angle is given to be 45 degrees. If I call this angle as x, then 90 plus 45 plus x is equal to 180 degrees. Therefore, x also comes out to be 45 degrees. That is, it's a 90, 45, 45 degree triangle, and we had learned that in such a triangle, the lengths of the sides AB is to BC is to CA is in the ratio 1 is to 1 is to root 2. Now the length of CA is given us as under root of 18, which is 3 root 2, which is thrice of its ratio root 2. So these two sides will also get multiplied by 3, giving the measures of the sides AB and BC as 3. Therefore, BC comes out to be 3. Now in this question we have to find out how many triangles are possible having perimeter as 14 and the lengths of its sides are integers. Now in one of the previous slides we had discussed a property which said that sum of the lengths of two sides of a triangle is always greater than half its perimeter, which is 14 by 2 here, and each side is less than half the perimeter. That is, A plus B has to be greater than 7 and A has to be less than 7. Now since we are given that the lengths of the sides are integers here, that means numbers like 7.1, 7.2 will not be allowed. So A plus B greater than 7 would actually mean here A plus B is greater than equal to 8. Similarly, A less than 7 will not have values like 6.9, 6.8. So A less than 7 here would actually mean A less than equal to 6. Now keeping in mind these two conditions, the maximum possible length of a side here can be 6. Therefore, taking the highest pair as 6 and 6, the third side will be 2 to make the perimeter as 14. The next possible pair is 6 and 5, giving the third side as 3 to make the perimeter 14 again. Next will be 6, 4 and 4. The pair 6, 3 has already got accommodated here. 6, 2 is already here. The pair 6, 1 won't be possible because it will violate this property. Coming to the lower ones, 5, 6 has already got accommodated here. 5, 5 will make the third side as 4. 5, 3 has already got accommodated here. 5, 2 pair won't be possible again because it violates this property. So any pair lower than 5, 2 will also not be possible. Coming to the pairs with 4, 4, 6 is already here. 4, 5 is already here. 4, 4 is here. 4, 3 again won't be possible, and any lower one will also not be possible because it violates this property. Similarly, going below, 3, 6 is here. 3, 5 is here. 3, 4 and the lower ones are not possible. 2, 6 is here. 2, 5 and the lower ones won't be possible again. 1, 6 is not possible and the lower ones are also not possible. So in short, only 4 triangles are possible such that the lengths of the sides are integers and the perimeter is 14. Now these are some practice questions for you to test your learning. These are the answers to these questions. I hope this session will help you to solve questions based on triangles. All the best for your preparation. Thank you.